So the topic we're gonna be going through is basically how we use React Native on the custom hardware that we've manufactured. There's a sample here that you can see on the table. We're gonna basically go through the challenges that we had, well, basically using React Native on it, and there's a lot of interesting things that we found out that I think is relatively unusual to a mobile phone, and a lot of things were quite simple. So I mean, a lot of these things we had to, well, roll out our own solutions. So about the hardware, we have a few interesting devices that we've previously built. This is a sample unit we've initially started with, which you can see on the table, which was more like a radio thing that you could put in your kitchen. We then this is something that we're planning to building probably next year. We call it the Mediacaster, which is pretty similar, but it's running obviously the same piece of software that we've been developing. We also have the Roxy, which is the latest model that we are using. It's a ARM CPU with a Mali GPU, which I think kind of older phones used to use Mali. We only have a half a gig of RAM, which is not a lot actually to play around with. So that means you have to really worry about how you take advantage of React Native. But actually, surprisingly, because it's a native app, it is an Android device, which we've seen a lot of Android devices having, they're low power, they have low memory, and mobile phones used to work on half a gig of RAM, and they were pretty powerful. So if we take the right approach, we can squeeze in a lot of processing, especially because we can take advantage of the hardware, putting our own chips on the hardware. For example, for a lot of the audio processing and a lot of the reverb effect, we actually have a specific the custom DSP chip, which is like a digital processing unit on the board that can actually speed up the processing of the audio. It also has an analog receiver for the microphone, so this is very similar to the kind of studio mics which use radio frequency. For the operating system, we use an Android open source project, so we don't actually use the Android phones that comes with a phone, because the Android on most phones come with pre-installed software and a lot of packages that we don't need. So you can actually find source of Android. There's a link. We forked it at one point, and we've been making a lot of changes since that point. I think it's really interesting how much you can get away with having a bare stripped down version of Android and actually choose which services you want, which services you don't want, which allowed us to save a lot of memory. We are 6 months in development. We are using the latest React Native version. So all of it works out of the box, which is really great for us because we did not find any challenges running React Native latest version on the piece of hardware. As long as it's an Android device, it seems to work. This is how the app looks, which we will have a live demo later on. We obviously are trying to push for a lot of visuals in terms of using large images, and all of it is being rendered at 1920 by 1080, which is a pretty high resolution image on your TV. And it's a lot different than a mobile application because of how it looks and how you can interact with it. And we think it's a little bit different from how most React Native apps look and feel. But at the same time, it gives us really fast iteration times, because we all know React Native is really fast to iterate. You can refresh using the hot reloading and hot patching and all that. So it gave us a really nice boost to be able to do this and take the step forward using it. Sort of the different dependencies that we have and the frameworks and libraries that we use. We use Redux for store management, state management, code push for JavaScript updates, Realm for persistent storage that we also are able to use as a database for querying. For example, if a user has made a playlist, we can save that playlist on the device and they can easily query and search their own playlist that they've created offline. We use TypeScript for being able to maintain and scale the code. We use Sentry for bug reporting, and we use Jenkins for the build pipeline, which is a little bit complicated just because we have to build not just the APK, but we are also building the actual Android image, where we bundle the APK within the image as a firmware update. So there's a little bit of that. So a bit of overview of what the problems I will be talking about. There will be a major subject on touch events. So touch events is quite interesting, which I will go through of different challenges that we had using it, the software updates and the future work, sort of where we aiming to be, and the actual some devices and the microphone that we're hoping to look a lot better, which I will come back. We'll all come back to it. So what's different between a mobile application and sort of a application on TV is that screen output is HDMI only, means that you have to plug in the box to an HDMI, which means it's a monitor or a TV, which means that it has no touchscreen. So we all know that no touchscreen means there's no touch events, and React Native is all about touch events. We all know that. So that gave us a bit of interesting challenges. So we had to basically design, we had to design a Roxy controller, which is one that you have on the table. It allows us to control the device, which I'll explain how. So it comes with a Bluetooth controller chip, so it allows us to pair it with the box. We also have a haptic feedback, so if there's any feedback, it would vibrate to let you know there's been an error. We use gyroscope and accelerometer, which can track all the movement and the angle, which allows us to do all the kind of interesting things, as well as pointing on the screen. Very similar to like a Wii remote, which I think some of you've used. Also has a microphone with a wireless transmitter, so we don't actually send the audio because it's a microphone. We don't send the audio over Bluetooth because Bluetooth usually has a pretty large latency when it comes to audio. So we use a FM, basically analog transmitter and receiver to be able to send the audio across with very little latency. And it's also a recognized mouse pointer using the human interface device. So you could actually plug in one of these via Bluetooth to any of an Android phone without any drivers. It could just pair it, and you would see a mouse pointer on your Android phone, which is pretty interesting that it just works. So the touchable opacity is where we started, which I think some of you have used. It allows you, or touchable feedback for some of you, depending on which one you prefer. So touchable opacity is basically a component that you would highlight and select. So for us, the OK button is the left, or sorry, not left, but the touch press event. So it works as a mouse, it just works. But we did find a couple of problems with it. Well, first of all, it didn't work very well for us. So I need to first explain sort of the internals of how the touchable opacity works before I can explain the actual problem. So with touchable opacity, if we, for example, want to create an icon component, we would create a touchable opacity component, and we would write the icon, which is an image, within the touchable opacity that makes the icon clickable. Makes sense. We would press on press to get the event. So we wanted to look at having something called hover events, which is something that you would, before you click it, you want to see the kind of glow or highlight before you actually click it to have some feedback that this has actually been hovered. So we looked at the interface of touchable opacity, and it had a lot of interesting things, but none of it was really something that we needed. You could provide on-press event, you could press on-press in event, but none of it was really to do with when you hover on it, nothing could happen. And sometimes we want to change the image when you hover on something, which wasn't possible. Now, it was also very slow when we noticed, because on a mobile phone, you usually have maybe up to 10 different touchable opacities, because on a mobile phone, it's a small screen, you can only press up to 10 items at a single point of time. For us, on a large TV screen, you would end up with maybe 30, 35 things you can click, just because we take advantage of the large screen. So when we started creating all the 40 different components, we started seeing a bit of a slowdown across the whole app and how long it took to render. And the reason why it actually took a lot to render is because a lot of things, like a lot of people probably don't use touchable opacity and providing accessible options, which allows the Android system to understand that this can be used using the voice, because there's accessibility settings that some people have enabled, which isn't the case on our platform, which means that we don't have to register that with the system sending unnecessary things over the bridge. It also allows you to define the hit slope and the press retention offset, which defines how far you can drag away before that touch actually registers. It's something also we didn't really need for every icon, and actually I will show in a while how much code there is behind touchable opacity. So this is actually over 1,000 lines of JavaScript behind touchable opacity. So this is the code that executes when you mount it. This is the code that executes every time you unmount touchable opacity. And this is the same for touchable feedback and all of the touchable components that everyone's using across React and React Native. I don't think there's any other ones, but please let me know if I'm wrong. There is also what happens when you actually press down or press touch down of a touchable opacity. All this code gets executed, and believe it or not, it creates 3 timers. And each timer is a JavaScript timer to time whether you have whether there is a delay in specified or whether there's delay out specified. All of these things you can customize. Was a lot of things that were happening on the device, which probably doesn't affect much on a modern mobile phones and maybe on a website, or I'm not sure how React Native would go on a website, but there are a few obviously layers that can be done. I haven't looked much into it, but from what we've seen, and this is what happens when you move while dragging. While you press down and you move your finger, this code will be basically calculating how much you've moved your finger, if it actually should register it or shouldn't, based on how much you've moved away from it, which we didn't really care about for all the little icons that we had. And if you've seen the photo behind on how the app looks, on the bottom you have maybe 12 different icons, which will be, you can go backwards of the playback music, you can go forward, you can enable shuffle, you can pause it, you can play it. There's a lot of buttons you can do, and we had to render all this with all this logic. So this is the render function of the touchable opacity. It doesn't do much. I think it just passes the properties down, but that's what it looks like from React Native source code. This is purely just copied from it. I didn't write it. And one interesting thing is, if you notice here, the style is it's being overwritten by the opacity of the touchable opacity, meaning that when you press down, the opacity of that view is already being overwritten based on if you've pressed it down or not. So if you wanted to make your icon fade in at the beginning of the whole app, you couldn't just pass opacity because that would have been overridden. So you would have to wrap the whole icon into another animated view to animate all the children to a certain opacity or fade it in. Which means that it would basically look like this, where you would have touchable opacity, you would have animated view, wrapping it, and then actually pass the opacity animation, fade in animation on the animated view, not the touchable opacity, because it just doesn't work. So we have animated view, we have touchable opacity, we're still missing hover events, so when you hover on something, there's no events you can get. So React Native doesn't have it. You have to go into the Android native layer to pass the information. So ideally we wanted something like this, where you provide a component which is a hover area, which is very similar to touch events, but there are hover events. You wrap anything inside and you get unhovered event. This is how it looks on the Java side if you implement it on the native side. It basically is using a Android set on hover listener, which is something that comes with every Android view. And it allows you to pass all the hover events down to JavaScript, basically passing it to the context, the React context, which allows you to then get the event back. So this is all the code we had. It wasn't that hard. We then end up with this, which is a render function for a single icon, which is a hover area wrapped in animated view, wrapped in touchable opacity. We all had this because we all know touchable opacity cannot take opacity, so we have to go back to animated view, and animated view doesn't have hover events, so we have to wrap it. So this is where we ended up. We've been doing it for a while. We realized it's really slow because we all know that nested views is bad for performance. There's something called double taxation for certain layouts. So even if you're just wrapping views for certain layouts like grid layout and linear layout, there is basically, just to keep it short, the layout exponentially grows the deeper that the children are, even if it's a simple component like this. So on top of the layout, you also have overdraw, which on Android has to calculate how much of an area has to go beyond to be able to compensate for any opacity, which means it can even redraw the same component 6 times just to be able to calculate how much of it overlaps, even if it doesn't overlap. So there's a lot of rendering kind of taking time and a lot of layout taking time if you do this kind of nested structure. So we were looking for, and iOS actually deals with it a bit differently. iOS using a GPU to define the Z-index, which solves the problem. On an Android, it's using a painter's algorithm, which is a little bit different, and it actually does not take advantage of GPU. It has to calculate the pixels and how much they overlap. So there's a bit of reference on the bottom if you want to read about optimizing view hierarchies. I think it's a useful thing that some people should maybe have a look at because there's a lot of insight. This is purely only if you're using Android as your platform on React Native. So we knew a few things. We knew that everything that's touchable must be hoverable, which kind of gave us a clue because you would normally, before you click, you want to have a feedback that it's been hovered. So we knew it's always the case. There would never be touchable without hover events. So that gave us a clue that we could try making it a single view because we don't have to have 2 separate components for it. But it wasn't easy. And we looked at more into what actually the props for a view. And first we started looking at animated view. We looked at it's the same props for animated view, same as view, except the style is being weakened purely because the style can accept animated values, which means the view props now extends gesture response handlers. So these are actually the gesture hand responders, which are the props you can actually pass into any React Native view. And I think a lot of people don't take advantage of these gesture handlers unless you're doing something like dragging or sliding. But I think very few people actually use these props that you can use on any view, regardless of what view it is. So we've looked into these props and we found that, before the props, we also looked at how we can create an animated component. So what is the difference between animated view and a regular view? It's actually the same thing, except the view class is being wrapped in a method called created animated component. This is, by the way, the whole implementation behind animated view. This is the same thing, just requiring a view and wrapping it in a method, and that method returns a class. So you feed a class, it gets a class back, and that becomes animated, which gave us a clue. We can pass in any view that we have, and we can make it animated and not have to wrap it in anything else. So we have a hover area we require from a native component. We can also do the same thing for animated hover area if we need to by just wrapping the class and we get a different class. We export those two to give us a bit of control over using it. We then have to implement touchable hover area, which is technically a hover area but provides the gesture handlers to be able to register a click. It also simulates the pressed opacity, which is basically the opacity when you click something down. When you release it, it would set the opacity back to 1, which makes it look like you clicked it. This is actually very similar implementation we've looked at for behind touchable opacity, except it's not 1000 lines, it's just a lot bare bones and something that worked a lot better for us. It was a lot simpler, we can actually control a lot of things, and it was very simple. So this gave us at the end, it gave us something called animated touchable hover area, which allowed us to have a single view, which does a single layout, does a single render, and allows us to have a hover area, something that you can touch and something you can also animate, which gave us to sort of finally being able to make an icon with a single view and sort of having an image that changes when you hover and unhover. A lot of work, probably took us 2 or 3 weeks. It wasn't that hard, but I think it's something that is unusual for React Native, but it's something you do once and then you can move very fast developing the rest of the app. So a few problems I had. I'm not going to go through them very much. So we had an issue where multiple things could be hovered at once. So on Android, when you have two views overlapping, when you put your pointer between them, technically they're both hovered, which is not usually how web works. You kind of want one thing to be hovered at one point. So we had to introduce Z-index on a hover area to be able to resolve what's actually higher than other elements. We also have hover area wasn't respecting pointer events. So if you want to have a view where you disable the pointer events, it means you cannot click anything within that view. You also don't want the hover events to kind of work. You don't want things to highlight when you move on this disabled area. So we had to compensate for that, which wasn't hard. This is the piece of where we intercept it and override it and make sure that it shouldn't propagate down. That was about it for hover events. The other major difference is software updates, which we were looking. It's actually one of the major differences between how you release and deploy a React Native app compared to something that you would release or update on this device. There are a few kinds of updates. There's the JavaScript updates. There are the application updates, and then we also had firmware updates to be able to update anything, like if there's a problem with the Wi-Fi controller or the driver, we would be able to patch it and release it as an update. And on top of that, the factory reset must work. So when you do a factory reset of a device, you want to make sure your app doesn't vanish. You want to make sure it's still pre-installed. So that's important how you release it and to make sure it's part of the system partition of the device. So a bit of overview how the React Native, where it lives. So we have a React Native app running as a user app. Means it doesn't have all the permissions. It can just render things. So this handles the JavaScript updates and the live content updates. Now we've implemented a package called Magic Client. I think a lot of you have done React packages before. I think they are the base of how you create native packages on React Native. So Magic Client allows us to basically have a bridge between the React Native APK and a different APK we call Magic Service, which runs as a system service and has all the permissions to be able to modify the system partition and all the other things that React Native shouldn't do. This gave us a bit of, the reason for this is mostly for separation of concerns and also being able to share our React Native app with third parties or share it with other people without having to disclose our Magic Service API, which is responsible for signing or verifying the signature of the firmware and all that kind of things we don't want to show to other people. So the Magic Service handles the APK updates, the firmware updates, and the factory reset as well. And we communicate between those two APKs that are installed on the system using a service connection that comes with Android. This is the rough code that you can create a React package. It basically creates a service connection with the other APK. It's not hard, but I mean it just sets the other APK name, binds the service, and being able to send messages to it. That's a React method, means that you can send messages to the service APK from React Native, and be able to receive messages from the other APK and send it back to React context, which means we only have to write it once, and JavaScript updates technically allow us to create new protocol and update the opcodes and do all the kind of things via code push. Firmware updates look pretty simple. The top part is the JavaScript. So I think some of you may have used a framework called React Native Fetchable Op. It's a very popular library that allows you to fetch files and save them on a file system. We would fetch the OTA update. We would save it on the file system partition, and we would then send a message to the Magic Client from JavaScript saying opcode update firmware using this file, and the firmware would then start installing and replacing the whole system partition with this specific image. This is we've seen this before. This is how you send a message to the other APK. So you can read more about Android services under that link. I think it's interesting. I think it's maybe not the most use case for a mobile phone, but it's something that is pretty interesting, how you can take advantage of the Android system doing a lot of the hard work for you in terms of having modules and taking Android to full advantage. So with building the app means that a lot of people here use code push, I think. We use Jenkins to do that for us because we like things to be automated and make sure we don't have to do it manually. This allows us to also build the React Native APK, which I think most of us do maybe on the laptop, but again, I think keeping it, I think there's also even App Center can build it for you as well. We like it to be part of the same pipeline, the same part of the same, as multiple jobs in the same pipeline on Jenkins, which the reason for it actually is because once you release code push, you want to take the bundle that the code push has built and then put it inside the APK that is gonna build next. The reason for it is that because then you can then take that APK and then package that inside the Android OS. So almost the bundling is happening from code push to the APK and then to an Android OS, which we have 3 separate sort of artifacts that would end up on S3. Those artifacts we use to distribute to the devices in different ways. So for example, if we have a new JavaScript bundle, the device would basically load the JavaScript bundle or update it using a component. We do not deploy the APK because we realized it's a bit too much hassle. We can just rely on the firmware updates which contain the APK. So that made the job easier, not having to maintain different firmwares with different APK versions. It's all kind of consistent. So it's pretty simple in a way of how we are building the APK and the Android OS. I think that's pretty much it on the building the app. We also had to design a custom screens. I think that's the last difference that we found between a mobile app and a React and sort of a building an app on a custom hardware. It's basically you have to build every screen. For example, this is the settings screens that we have on the platform, and allows you to change different configurations of the device. And we also have a choose Wi-Fi network screen, which allows you to choose the Wi-Fi, because exposing an Android Wi-Fi screen isn't really ideal for a customer. And if you do see it, it probably means it's broken, because you shouldn't see it if you do. So we had to make our own, which was a bit of obviously a difference. So future work, we have a few devices planned. We have a new controller that we're working on, which is, instead of the fabric that we have on here, we're using a metal mesh, which allows for a sort of a better voice, but at the same time it doesn't get dirty, which means we can actually produce it in a white color. It has a capsule mic, which is a lot better than a condenser mic, which is here, which makes a better quality for singing and for voice commands. And is also a better quality in terms of there's a LED ring, which is RGB, which you can feedback with a different color in terms of what's happening on the screen. So if the music's playing, you could make it spin, which is a really nice effect. We also have a few devices that we're hoping to build in the future. And I think a lot of things that we would love to do, and we definitely would like to have and hire more people to be able to do this and achieve what we like. If you like what we do and you're interested, we have 3 open roles that we would like to hire. And you can find the full job spec on Hacker News, just down below. And that was pretty much our story. That's all the challenges we had to make. Cool. I think that's everyone. Yep.